Hello, everyone, and welcome to the Serverless ETL using Altis DLA and AWS webinar. So my name is Manan, and I'm going to be presenting this webinar for you today. I'm going to get started now. I think some people might still be joining, but if you've registered for this link, you will be getting the recording by email at the end of the webinar. So please keep an eye on that. I want to thank you all for joining me today. It's probably going to be about a 30-minute session, and there will be time for questions at the end. And so jumping right in, let's get to the agenda. So what I'm going to cover off today is a little bit about Altis and myself, and then I'll speak briefly about the relationship that we've had with AWS over the last couple of years. And then we'll get into the bulk of the content for this session today. So it's going to be a lot about what is the Altis DLA, what do I mean when I talk about a serverless ETL, and then we'll get into the high-level architecture of what I'm presenting today. I'll finish off with the benefits of serverless ETL and the Altis DLA, and then I'll finish off with a case study that explains some of the business outcomes that we realized when we implemented this architecture for a particular client. So there will, as I mentioned, there will be time for questions at the end, but if you do have a question throughout the presentation, please feel free to shoot it through using the Q&A section of Zoom, and I'll try to answer it as they come up, or I'll try to answer them at the end. Please do stay tuned for the next steps, as it's a pretty important information that I want to share with you at the end of the webinar. So Altis is Australia and New Zealand's largest privately owned data and analytics consultancy. We've been around for 20 years, and we've been using our industry experience combined with our technical capability to deliver some tangible business outcomes for our clients. We have offices across Australia, New Zealand, and the UK, and we are now over 120 staff strong. Our products and services range from advisory through to delivery through to managed services, and they're across several verticals of data, information, and analytics. But as I mentioned, our main focus is to actually deliver some outcomes for our clients. So a little bit about myself. I've been with Altis for about 4 years now, as of last week, and I have worked on a range of projects for a variety of clients across several industries. Mainly these projects involved data warehousing and reporting, data ingestion and validation, and a couple of pieces on data quality as well. More recently, though, I've been involved in a number of projects where we've implemented the Altis DLA. So our relationship with AWS, we've been a partner with them since 2013, and we established a specific practice in 2016. We have service delivery accreditations in Redshift, Lambda, EMR, and Kinesis services. We recently completed our data and analytics competency earlier this year. We have over 40 customers across Australia and New Zealand, and over 20 of our staff are certified and accredited. So getting into the content for this webinar, what is the DLA? I think some of the marketing material we sent out earlier for this webinar had this term as DLS, so we recently renamed this tool, but basically it stands for the Altis Data Load Accelerator, and essentially it's a tool that we use to accelerate the development of an ETL process. And the way we do this is that the DLA simplifies the data loading process using a set of predefined code and a set of guided patterns that we implement in your environment. What I mean by a preset code is essentially a set of stored procedures, a set of tables, set of views that we deploy into your database platform. In this case, it's AWS Redshift, that we use to orchestrate and execute the ETL process. So we've taken our experience of developing ETL processes over 20 years, and we've sort of generalized what we think works well, and we've made it very feature rich, so that out of what you get out of this preset code is a lot of functionality. It's very flexible, though, at the same time, and so you can use this to implement a lot of your common ETL user requirements. When I talk about guided patterns, this is essentially the overall orchestration of your ETL process. So we have a set of patterns that we use to implement this orchestration, as well as we have a set of patterns that we use to extract data out of common source systems. And I'll speak a little bit more about that towards the end of the webinar. So this entire process, when we talk about DLA, is metadata driven. And again, I'll speak about this in more detail when I talk about the architecture. But essentially, we use metadata to drive this whole process. And this is all at the object level. So when you're talking about a table in a database platform or a particular API, we define it at the object level. So it's very high level that you need to define your metadata. The DLA, as I like to explain it, is split into two parts, and to align with the traditional ETL terminology, we've kept it similarly named. So in the extract side, we extract data out of your source systems and we bring it into your staging layer of your data platform. This is where we connect to your data sources and do all of the logic that's required to bring the data out of your source systems into your initial layers of the platform. And then the load side is where we transform and apply any business logic that you need to apply to move the data from your staging layer into your presentation layers of the data platform. Now, I've left presentation layers here as a very generic term, and I'll explain a little bit in more detail later on why that's a generic term. So in the context of ETL processes, what do I mean by serverless? So commonly, when we have ETL architectures, they would contain several server components, and these could be for various use cases. Potentially, you might have servers in place that are actually executing your data pipelines, and you might have a couple of servers that are allowing you to connect back to your on-premise data sources as well. And you may have servers that are running for some other use cases as well. So in a serverless environment, what I'm talking about is running code, applications, or ETL processes, data pipelines, basically without provisioning any of these servers, and therefore you no longer have to maintain any of these servers, which allows you to basically have a very simple setup, a very simple operation and management of your ETL process. It becomes very flexible for you. It can be very auto-scalable, and it's also very highly available and fault tolerant. In most cases, it can be a lower cost for you as you're not provisioning servers to run and you're not spending any cost in maintaining them in the long run. And in most cases, when implemented correctly, it can lead to a more efficient data pipeline for your ETL process. So to orchestrate the Altis DLS in this architecture where we're talking about using AWS to implement a serverless architecture, we use two services within the AWS environment, namely step functions and AWS Lambda. I'm going to talk a little bit about these in detail and how we use them to create this serverless architecture. So starting with AWS Lambda, this is essentially a service that allows you to run code without provisioning and maintaining servers, as I mentioned. And the key point to mention here is that you pay only for the compute that you actually utilize. So if you've got a Lambda function that you've developed and you have running, you only pay for the resources that you have configured and for the time that this function is actually running. So it can be a very effective in terms of saving cost and optimizing your data pipelines to run just with a very specific configuration, only for a very specific period of time. Now, AWS Lambda itself supports many programming languages, including Python, Node.js, and quite a few others. And so what we do is we utilize this service to actually build the code part of your ETL process, which allows us to basically run the ETL process without having any physical service provisioned as part of the architecture. A little bit more specifically, within the Altis DLS, we use these functions for two purposes. The first is to extract data out of your source systems. As I mentioned, these could be databases, these could be APIs, these could be some sort of file sitting on a location somewhere. And we use these Lambda functions to connect to these data sources and bring the data out of them. We also leverage the Altis DLA's features to help you do this extract. But I'll leave this fairly high level and say that we use these functions to extract the data out of your source systems. Second use that we have for AWS Lambda in this architecture is that we use it to interact with the AWS Redshift. And we do this through the Redshift Data API. And this is really important, and I want to stress this a little bit here, because what this allows us to do is not only are we connecting to your data source and your AWS Redshift cluster through a serverless service, but we actually only run these functions for as little time as we need to. And the reason we can do that is through this Redshift Data API. So very briefly, without getting too technical, what we're able to do through this mechanism is execute a query or a set of steps in Redshift and then exit the Lambda functions compute time. The reason we do that is because essentially once you've triggered a step in AWS Redshift, we don't need to have the server or the AWS Lambda function continue to run, because the Redshift cluster will take over from there. And so what this does essentially is it leaves you, not only are we removing the need for you to provision any servers and have them running consistently, but even without that, we are running the serverless service for as little time as possible. So it can be a very efficient way of running your data pipelines, and it can be a very good way to save on any costs associated to your compute or server resources. But this is the main service that we're using to actually implement code and to run code. But we need another service to actually orchestrate the overall process, and that's where AWS Step Functions come in. So this is a service that is mainly used to design and execute different workflows that sequence various AWS services, such as AWS Lambda, and they allow you to efficiently build and deploy serverless processes. So we use this AWS Step Function service to orchestrate the execution of the ETL process. And what this allows us to do is manage things like the parallelism and the restartability. So in an ETL process, if you need to run a set of jobs concurrently, we use the step functions to orchestrate that. And if you want the ETL process to restart, depending on the type of failure, we can manage that again using step functions. And obviously, if the failures lie outside of this, the requirement where it needs to restart, we would handle and log any failures that occur using these step functions. So it manages your overall orchestration of the ETL process. Obviously, the step functions would call the AWS Lambda functions that I mentioned earlier, and these both of these services rely on the AWS, the Altis DLS configured in the AWS Redshift cluster. The three things in combination work together to orchestrate your ETL process. So I want to talk about the high-level architecture of the actual DLA and how it ties into the AWS serverless architecture. But before I do that, I want to set up just some basics. So once you have the DLA implemented into your Redshift cluster, and you've got the associated AWS step functions and AWS Lambda functions implemented in your AWS environment, to define or to bring in a new data source or to bring in a new object from your data source. And when I say source object, I mean, it could be a table from a database, it could be a module from an API, it could be a file or anything like that. All you need to really do is configure the metadata. And although we have in the DLA several different metadata options that you can configure to basically accommodate for various use cases that you may have. You might have a complex data source that you need to bring data in from that may have a series of steps that you need to execute. But at a very high level, what you really need only to run this process is what source system that you're connecting to, what is the source object that you're trying to bring in, and what data load pattern that you want to use to bring the data in. I'll talk about these four in a little bit more detail once I bring the screen. But I want to spend some time talking about this overall data flow. So the data flows from your data sources, and as I mentioned, we use the combination of the step functions, the Lambda, the DLA sitting in Redshift to bring the data into a landing layer. Now, this landing layer is most commonly a schema within AWS Redshift, or it can alternatively be a Amazon S3 landing bucket. But for any hybrid data lake or data warehouse and data warehouse components, it can also be both of those components. So what you get is the data moving from your data sources through this orchestration into your initial layer. And then we use the DLA again to basically bring the data into your staging layer. I want to talk about some of these data load patterns briefly. These are just 4 examples that I've picked out, and they can be configured to suit various set of use cases. And there are a couple of other ones that I have not mentioned here. But these are the main ones I like to talk about because they fulfill a lot of the common requirements that we see coming up when we implement the DLA. So if you have a transactional source system where you need to bring data in on a daily basis or potentially on a particular schedule, and you just need to append it to what you have existing in your current data warehouse, we have an append data load, which will basically add that data into your existing information. We also have a merge pattern, which basically says if you have a data coming in again on a schedule and you want to overwrite any data that exists previously and add in any new data that didn't exist previously, so that merge pattern can be used to fulfill those requirements. The delta and full apply patterns are basically where you have a source system where your data may be changing and you want to capture those changes in your data warehouse. we can use one of these load processes to bring the data in and capture those changes for you. So what you get at the end of the extract process in the DLA and this architecture in your staging layer is a complete copy of your source data that you've loaded, and where you need to capture any history or any changes that will already be done for you. Which brings us then to the load side of the framework, or the DLA process, where you actually implement your transformations and your business logic. And you define this basically as a view in your staging layer, and then you define in the metadata that view as the source. You define the target table that you want to load, and basically you define the load pattern again that you want to use to load this data into your presentation table. The architecture then becomes a little bit more simple for this side because we're going from Redshift to Redshift. And once again, you see that we're using step functions and Lambda to orchestrate this process. And again, the DLA supports this so that you can apply the particular load pattern. And here's where I want to get into some explanation of why I said the presentation layer, I use that as a generic term. Because more often than not, what we've implemented is a traditional dimensional model data warehouse type of presentation layer. But what we have also done using the same code base and the same DLA features is something like a data quality presentation layer. We've done a reconciliation, we've implemented some testing presentation layers as well. So what I'm trying to say here is that the presentation layer can be very much what you want it to be. The underlying code is very generic and the features are very customizable, in that what we're trying to generalize here is not your logic or the transformation that you're trying to apply. That remains in your control and it remains very customizable and flexible. What we're trying to generalize and automate is the actual process of pushing the data from an area to another area. And so it simplifies the development process a lot because you're not rewriting the same code over and over again. It allows you to spend the bulk of your time actually adding value by defining business logic and transforming your data into something that adds value for your business. So then there are a lot of benefits to this, the serverless ETL and Altis DLA architecture. And I've mentioned a couple of them already while talking about the services that we use, but I want to highlight 3 of them in this section. And these are the 3 that I think are the most important. And I hope that this is what you take out of this webinar today. So if you implement an architecture like this, the first thing it gives you is a centralized ETL. It gives you this, all of your services and all of your components reside inside the AWS cloud. And this makes it very easy for you to maintain this platform. If you're talking about your scheduling, your logging, your security, and your billing, everything is maintained within the AWS platform, which becomes very easy to maintain. Can become quite easy to report off, to operate, to maintain in one location. What it also gives you is a very simplified ETL process, and this is where we're bringing in the Altis DLA features as well. So the step functions and the Lambda functions are generic and reusable, so they can be very easy to set up initially, and then you keep reusing them as you go. And the DLA, as it sits in Redshift, is extremely flexible, and it's very easy to use. It's written entirely using Redshift SQL, and so your developers or new users can become familiar with the SQL code very easily. They can customize it as they need to. It becomes quite easy to extend to suit whatever you need to use it for. It's completely metadata driven, as I mentioned, so you only define your metadata at the object level. So if you're bringing in a table, for instance, from a database, you only specify the name of the table. You don't need to define which columns to bring in and what they're called or anything like that. So what this gives you essentially is a process where you can very efficiently and very quickly bring in the data into your data warehouse. And why this is so important for me is because traditionally we would have to analyze the source system and the data structures that we need to bring into an ETL before we actually design an ETL process to bring the data in. But what this allows you to do is bring the data in, analyze it in the format in your staging layer that you're going to be using it in to actually design your transformation and logic to expose this data and add value to the business. So that whole development process becomes very efficient. It becomes very robust for your developers to rely on. So the predefined load patterns as well in the Altis DLA make it very efficient. As I mentioned, you're not rewriting the same code over and over again. So the overall speed of development becomes very, very efficient. The last thing I want to mention again is the serverless ETL. I've mentioned this a couple of times already, but I want to highlight the fact that you're not having to provision any or maintain any servers put in this architecture. And you pay only for the time that you're actually running your compute, which can become a very big cost save for you and becomes a very efficient way to run your ETL pipelines. The other thing I want to mention here is that this architecture is extremely scalable. So let's say you've got a new data set you're bringing in, and it's potentially a bit larger than you have been the data sets that you've been loading previously. And because you're not maintaining or provisioning any servers, to increase your compute power, it's very easy for you to configure that using the Lambda functions and step functions. You can easily increase the amount of power that you have or the configuration that you have. Your resources that you have available to your compute are extremely scalable. It can also make for extremely fast deployment. So because you're not maintaining any servers or provisioning any servers, the only thing that you're maintaining is your actual code base. So when you make enhancements, when you make additions to your code, the only thing you have to deploy is that code itself. So it can become a very fast development lifecycle, which means that you can deliver value to your business at a faster rate. As they give you feedback, as you develop new, as you bring in new data sources, you can deliver them a lot faster. So I want to finish off with a case study, and this is talking about where we've implemented this new architecture to replace an existing ETL process for a particular client. Their existing ETL process relied on a third-party ETL tool, which they had on top of an AWS Redshift cluster, and they had AWS EC2 servers that were basically running this ETL third-party tool. The project itself involved obviously the implementation of the required step functions, the Lambda functions, and the DLA code in Redshift. It also involved the analysis and migration of the old data pipelines that they were running and translating it across to the Redshift DLA. We also integrated 2 new data sources as part of this project, and we used a new process to bring these 2 new data sources into the data warehouse. What I want to highlight about this particular case study is the business outcomes that we achieved throughout this project. So at the end of the project, the data that was previously sitting in AWS Redshift cluster was now loaded using the new process with no interruption to any downstream processes. So we were able to test, develop, test, and then deploy the new process in such a way where on a particular day, the same data that was being loaded by the existing process was then on the next day being loaded by the new process. So there was no interruption to any downstream reports or any other process that were consuming this data. As I mentioned, we loaded 2 new data sources successfully as part of this migration, and over 20 of the old data pipelines were completely decommissioned, and we were able to streamline them into 3 new master pipelines. And obviously, any of the EC2 servers within AWS that were being used by the old ETL process and the associated third-party tool, we were able to decommission those, which in the long term saves a lot of cost and a lot of ongoing maintenance activities as well in the long term. That actually brings us to the end of the webinar. I'm going to open up the Q&A section to see if there's any questions coming through. But if you have any questions now, please shoot them through now and I'll try to answer them at the moment. I've got a question here asking about what is the deployment method for the framework, including Redshift and Lambda, and roughly how long does it take to deploy? So with Redshift code, we've mainly used Liquibase to do the deployment, which is an open source tool available for several database platforms, including Redshift, and it makes it very easy for us to deploy the Redshift code across several environments. And it's quite efficient and quick. It takes usually about a day to make any changes, probably a bit less than that actually in most cases, depending on the complexity of the changes that you're deploying. And in terms of Lambda code, we haven't put in place yet a proper CI/CD pipeline, but it's something that we're looking at the moment for a particular client. And so at the end of that, we should have something robust that allows us to efficiently deploy this Lambda code as well as the step function code into AWS. And I've got another question here. Looking at the use case, how do we compare the performance and price against using AWS Workflow and Glue jobs? So it's pretty difficult to compare unless we have a good understanding of the actual number of pipelines that we have running and the complexities of the data sources involved. And so I think the best way for me to answer this would be actually to get a good use case. If you could get in touch with us and explain what your current use case is that uses AWS Workflow and Glue jobs, and we could compare that to an architecture where we're using Lambda and step functions instead to get a good idea of how many pipelines exactly would be necessary. and how would the cost difference look like. In terms of performance itself, it should be pretty similar, and ideally, potentially could even be more efficient, as I mentioned, depending on how it's implemented. But again, it depends on the size of the data sources coming in and the interval that we need to process them in. That was that question. Sorry, I didn't answer live. Let me answer the next question. How does the DLA do with error handling, i.e. the Lambda executes a long-running code on Redshift that fails halfway through? So that's a very good question. So when we call the Redshift store procedures or some sort of step in Redshift, we execute it through the Lambda API. As I mentioned, we interact using the Redshift data API through Lambda. But basically, once that call is made to the Redshift store procedure or the query, we then exit the Lambda, and the step functions will have a process that basically keeps checking for the result of that query. If it detects that query actually failed, it will then handle the error and log any errors into two places. It will obviously fail that execution of the step function. So in the AWS console and CloudFront logs, you will get that particular execution has failed. But inbuilt into the DLA, we also have a set of logging components and tracking of executions. So you get the logs actually recorded in the database itself in the Redshift cluster. So you can monitor your executions on a daily basis in both places. And we've got another question here. What is the cost of the Altis DLA? Can it be self-installed and administered, or does it require consulting time from Altis? So the cost of Altis DLA, unfortunately, I'm going to have to answer it in a very similar way. It really depends on the configuration that you're after. So what you're asking us to implement the Altis DLA for. It can't be self-installed, unfortunately. So we do need to administer some sort of consulting time to set it up in your environment. It usually takes about a week or two to do this, and can vary, as I said, depending on the configuration that you're asking us to implement. But yeah, if you do want to know more details about the cost of the DLA and implementing an architecture like this, please do get in touch. I'm going to flick over while I answer these questions to the last slide, which has our contact information. So please do take note of that. And as I mentioned, you'll get the recording of this webinar at the end, so you'll have this information there as well. And before I get into the last couple of questions, I'll mention this here. As I said, the next steps are very important. And so I want all of you to take note of this, is that you have the opportunity to get in touch with us to learn about how you can potentially get some funding to set up an AWS proof of concept using Redshift or serverless architectures. So please do get in touch with us, and we can explore this opportunity with you in more detail. So another question we have here is, can this be used to load to a data lake instead of Redshift? It's something that we're still currently exploring. I think it's definitely possible. We haven't done an implementation like that yet, but there are some where we've done a hybrid implementation where we have, as I mentioned, the initial stages when you're bringing the data into the data platform. You have a hybrid situation where you might load the data into a data lake as well as Redshift. And so it's definitely possible for us to explore an implementation where we're loading only to a data lake itself. And we've got another question here. So how much details will we see in CloudWatch if we want to debug or troubleshoot the data pipeline? So as I mentioned, you get the data, you get all of the logging or troubleshooting information in two places, in CloudWatch as well as data pipeline. And the best way I can explain this is a lot of the orchestration is maintained through the step functions, as I mentioned. And what you get in CloudWatch, if a particular execution fails, is you'll get the exact step at which it failed. But if it's a database query or a component within Redshift that actually failed, you will get a full error message that explains exactly which procedure and what was the error message within Redshift within your CloudWatch logs. And the same information will be presented in your database cluster as well in terms of the logging against, and it will be actually logged against the very specific execution of a very specific data pipeline that you're running. We've got a question, another one for, would this work using Apache Airflow? Yep, definitely. I think we could definitely make it work with Apache Airflow. Instead of using the step functions, we will be using Airflow. Potentially we may replace the Lambda functions as well. We'll just be using Airflow. What is the backend code DLA is running? Is another question. Is it Python or PySpark? It's actually completely SQL. So the DLA code sits completely in Redshift. It's a combination of, as I mentioned, tables, views, and stored procedures written completely in SQL that sit inside your Redshift cluster. The Lambda functions themselves in this example are running Python, just if that's what you're asking in terms of how do the Lambda functions, what language are they running? They're running completely using Python. I've got another question. Is the DLA customizable? How would we implement non-standard extract and processing logic? The short answer is yes, it's very customizable and it's very flexible. So what we've designed as the DLA is essentially a set of patterns that we think come up more often than not. So if you're running an ETL process, 90% of the time, your patterns are probably going to be something that we've come across before. And so what we've done over the last couple of years is bring all of that experience together and develop this ETL in a way that covers off a lot of the common functionality. And obviously, as we've implemented this DLA on several clients now, we've found that there are some complex data sources that require some non-standard extract and processing, as the question has asked. And so we've been able to build that into the DLA. And as you said, it is very customizable for us if we're working with you to implement the DLA and we find a use case where we have a common set of data sources that need a different type of extract and processing logic. It's very easy to customize the DLA to accommodate for those requirements or to actually make it easier for you to fulfill those requirements. The best example I can give of that is where you might need to, for an API data source, you may need to execute multiple calls before you can actually obtain the data source or the data set that you're after. And we were able to build this in very easily to the DLA. It's all run through the metadata of the DLA completely. So it becomes very easy for you to run complex data sources through the Altis DLA. Another question we've got here is, once implemented, what skill set would an ETL developer require to develop or maintain the ETL processes? As I mentioned, because of the way that it's set up and the fact that your step functions and Lambda code are so reusable, in an ideal deployment of this ETL process, the only skill that you then need once you've set it up is SQL skills to run the process in Redshift. Obviously, once we deploy it and we would train up your developers to be familiar and completely across what has been implemented in AWS step functions and Lambda, ideally they would be mainly focusing on running the SQL code in AWS Redshift, just configuring metadata to basically define your business logic as views, as I mentioned, and configure the metadata to run the overall process. And your code that's sitting in AWS Lambda and step functions would be completely reusable. How many AWS customers are currently using the DLA? So I think the most recent number that I've found is we have over 10 customers now within Australia who are now using a version of the Altis DLA. Hopefully that answers that question sufficiently. So yeah, we have customers across various industries. We've got a media company, we've got government companies, we've got transport-related clients as well. It's across various customers across various industries. And I think as of last week, it should be over 10 customers that we now have in AWS. Any other questions? I think I've answered most of the ones that have come through thus far. And once again, I want to reiterate that this slide that's on the screen right now, please do get in touch with us and leverage this opportunity where you can potentially get some funding for an AWS proof of concept. We've got another question. Can Altis DLA SQL code be accessed, read, or modified by us when deployed? Yes, completely. So basically, once you have the Altis DLA code installed in your environment or implemented in your environment, you can take full ownership of that code. You can access it, you can read it, you can customize it as much as you need to suit your requirements. It's completely up to you how you take that code and what you do with it from once it's implemented. And obviously that would require some training. So as I mentioned, once we implement it, we do spend some time training up your internal staff to become familiar with the internal processes of how the DLA works. Any other questions before we complete the webinar? I want to thank all of you for attending this session and for all of your questions coming through. It really makes us glad that you guys are interested in this architecture. It's, as I said, I'm very passionate about this sort of architecture where it's really helping our clients save on their ETL process runtime as well as their costs, and makes the entire process for you to develop a data platform and maintain it in an ongoing basis and deliver some tangible business outcomes at a faster rate for your business. I don't see any questions coming through anymore. So I think that brings us to the end of the webinar. So once again, thank you all very much for joining. Again, you'll get a link to this recording via email if you've registered. And so keep an eye out for that. And you have the contact information on screen now. So if you want any more, if you have any questions later on, please feel free to get in touch, and we'll be able to answer any other questions you have for you. Thank you very much. And I will talk to you guys later.